Hey, Year 12s. Here's a quick rundown of today's lesson um, on reciprocal models. To start out, we have this example given to us. It says the time taken in hours for a road trip at speed x, so that's important that our speed is x, in kilometers per hour, is given by the reciprocal function t equals 2000 over s. So we know that the amount of time is t, and we know the speed is s. Okay, so what I'll start out with is we're going to construct a table of values for s and t. So how long it takes is like our y value, so that's like our y, so that's going to go on the bottom, so I'll put t down here and I'll put s on the top because that's like our x. The next thing we need to do is decide on some values. Now, if we're talking about a road trip and we're traveling in a car, some reasonable speeds for a car would be speeds like 10 kilometers an hour, 20 kilometers an hour, 30 kilometers an hour, 40, like those are reasonable speeds for cars to travel. So when you're picking these values, you don't have to pick crazy values, and that's why I knew to pick these, is because I was thinking of reasonable speeds that a car would go. Instead of picking 1, 2, 3, 4, I'm picking reasonable speeds that a car could logically and reasonably go. Your car can go these speeds, and they do commonly go these speeds. So once I've written my different values down for possible speeds a car could go, and we'll go all the way up to 100 because I believe that would be similar to Canada, that's as fast. I have seen a couple spots where you can go 110. I haven't seen anywhere I can go 120. So now I start completing my table of values using t equals 2000 over s. So I'm going to now substitute these values in here on my calculator, okay? So if I substitute 0 in and I have 2000 over 0, that's going to make no sense. It's going to be undefined. So I'll just draw a line through there because that's not possible. We do not actually get a value for that. So I just wanted to make sure I reviewed that with you really quick. The next thing is if I substitute there in 10 in for s. So if I substitute 10 in for s, on my calculator I type 2000 divided by 10. I think I don't even need a calculator for that one. I think I do that one in my head and get 200. Alright, so next I do, I substitute 20 in for s. So 2000 divided by 20 gets me 100. If I type 40, so 2000 over 40, I get 50. If I do 2000 over 50, I get 40 on my calculator. If I put 60 in for s and do 2000 over 60, I get 33 minutes, and this would be, hours, and I'm getting these all in hours. So I knew it was hours. If I do 2000 over 80, I get 25 hours. And finally, if I drive at about 100 kilometers an hour for 2,000 kilometers, it's going to take me approximately 20 hours. So there we go. I've constructed my table of values. Check. So next I got to draw my graph, and I had tried to draw this well. Let's see if I can scroll down a bit. Oh, I can scroll a little bit. Okay. So I have my table of values right down here. So down here at the bottom we'll have time, and then we're going to have our speed here on the side. So time usually goes on the bottom. Again, I only included the positive side of the graph because really you can't get negative time, number one, and getting a negative speed would also be very tricky. But the main one is you can't get negative time as well. So that's good to start. And actually, I've kind of made a mistake here. Let me just backtrack a little bit. Because I said to think of this like x right up here and y right here, I should also graph them appropriately. So I'll just backtrack a little bit. I made a little bit of a mistake there and a little bit of a mistake there. This should be because x is the independent variable and speed is the independent variable here. We will put s on the bottom and we'll put time on the top. The next is if we look at the increments of our graph, we know that we've got to get up to about 200. So if I went up by, let's make that, let's see, I may have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I went up to 200 here, And I think each time I'm going up by 10s there, so that would be, or I'm going up by 20s there, right? 20, 40, 60, 80, 100 would be right there. 20, 40, 60, 80, 200, perfect. And so that would give me, that's good. So that would be 20, 40. I'm just trying to write a couple values in so it's a little bit easier to do this. 100, 140 would be right there. You would be able to do this a lot more easily. Writing with my finger on a screen is very delicate and not easy to do. So I would put the rest of them in, and the next thing I can do is I have to go up to about 100 hours. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 hours. Because I know my time is about, sorry, I got a cough here. Sorry, my speed is 100 kilometers, so I know I should go up to about 100 here for speed. So there's 100 right there at that tick right there. Okay, so let's start graphing. I'll graph in blue. So to start, we cannot graph this because at 0 speed, time is undefined. It's going to take an indefinite amount of time traveling at 0 kilometers an hour to go 2,000 kilometers. So that makes actual sense. So we'll do speed at 10. So there's our first spot at 10 right there. And that'll be about 200. And sorry if it's not accurate. It's really hard to draw these on my screen. So next we'll go to we'll do 20 next. So at speed of 20 kilometers an hour, I'm gonna go, or it'll take me about 100 hours. So that would be right there. Sorry again if it's messy. So that's that one done. For 40, so that's 40, which is right here. 40 hours, or 40 kilometers an hour, it would take me about 10, 20, 30, 40, 50, and that would be a time, 10, 20, 30, 40, and a speed of 10, 20, 40, 50, so that would be right there. I'm just doing this properly. There we go. Sorry, with my 1,000 touches to the screen to try to get my dot, so that's that one done. Next, 50. So my speed of 50 is right here, and that would be at 50. I would go about 40, or it would take me 40 hours. Sorry. There we go. That's that one done. At a speed of 60, so I'm right here now. At a speed of 60. It's hard to do 33. I'm going to try my best to kind of approximate that. Right there. My speed of 80, which is next. 80 is nice because it'll be at just above 20. So it'll be there-ish. Sorry, my screen is not very exact. And at 100, it will get me exactly 20. So now, again, I'm going to try my best to do this. Sorry, that dot should be a little bit up on 20. I'm just having a hard time drawing it because of the screen. So next I draw my curve. Not as terrible. I missed my dots, and again, forgive me. Drawing on a screen versus drawing on a piece of paper are two very different things. So there's my function of t equals 2,000 over s. So that's good. The other way to think about this is the reason why we've put time as not the bottom value is how long it takes us to get there depends on how fast we travel. So we always put our independent variable on the bottom and the dependent variable on the side. And that's also why time is our vertical values, because it's dependent on how quick we go. How long did the road trip take at a speed of 70 kilometers an hour? So the first thing we can do is we can take our graph and we can approximate. So we read to 70, so 100's here. Sorry, I got 100 here. So 90, 80, so 70-ish, and I read on my graph and I look to see where my line intersects with 70. So this is a little tricky because, as I said, it's very messy, but I know it's going to be probably somewhere between 33 and 25 hours. So it kind of gives me a rough estimate of where it's going to be. That rough estimate, probably could be estimated. We could probably look at it and probably think, maybe around 30, 29-ish for 70. but we can also be exact, don't forget. So what we can do to find that is we can go, well, we can say, what is t equal if we went 2,000 divided by 70, and this is where we can get a precise answer. We already know the range our answer should be, so we know what should be reasonable. And I get a value of 28.57, so that's right around where I estimated it to be. And there we go. So it's going to take about 28.57. And what did we say? Was that hours? I believe, yeah, hours. Okay, good. Why is it impossible to complete the road trip in 10 hours? Well, it's impossible to complete the road trip in 10 hours because I wonder how fast we'd have to be going. Let's look at that. So to do that, I'm just going to erase my work real quick. So you can also look at this as a quick algebra question, and it'd be really easy to do. So let's just do that real quick. I'll manipulate that, and then you can get going. So if you wanted to do the trip in 10 hours, and you have to go 2,000 kilometers, and that's over the speed, so you got to find speed. What I'm going to do is I'm going to use my crossover trick that I've shown you guys before. I'm going to cross multiply 10 and s, 2,000 and whatever 10's over. And don't forget that 10 is actually over 1. So that equals, what's 2,000 times 1? Yep, it's 2,000. And what's 10 times s? Well, it's 10s. I divide by 10. I divide by 10. And my speed to make this trip in 10 hours would be 2,000 divided by 10, which is 200 kilometers per hour. And it would be impossible to complete the road trip because that is wildly speeding. And I really hope that you never are going 200 kilometers an hour on a 100 kilometer an hour highway, because that is a huge traffic infraction, traffic ticket, and you're breaking the law. I don't know if it's same in Australia, but in Canada, you could even almost get your car impounded if you're going that fast. So that is why not. I believe in Germany on the Autobahn you can go quite quick. Maybe in Germany you could, but in Australia it is impossible because you're not allowed to go 200 kilometers an hour on the highways. I hope that helps you out with your work, and I hope you're all doing well. Take care.